Generally speaking, there are two schools of thought when it comes to separating logic between your scripts in Unity. You can either split up your game into small component parts, where individual behaviours each live in their own self-contained scripts, or you could do the complete opposite of that, and put all of your logic into fewer, large, single-purpose classes, or anything in between. In extreme cases, you could even put all of your game logic into one class, which seems really, really bad. But is it? If you've watched any of my videos, or if you've tried my Unity scripting course, then you probably already know that I'm a strong believer that it's more important that your Unity project is easy to work with, and by that I mean easy to change, than it is to blindly follow best practice scripting advice. Which means that if writing your entire game in one script is the easiest way for you to do it, then go for it. But how will you know if it's going to be easier? When you're planning your project, it's difficult to know in advance what easy to change will look like later on. In this video, I'm going to show you how to decide what should go in one script and what should go in another, based on your project, so that you can build your game in a way that's easy for you. So, what should each script do? If you follow the rule of single responsibility, then generally speaking, each script should be focused on a single task. However, this is easy to misinterpret, and taking it too far can make your game harder, not easier, to work with. After all, splitting your scripts up means that you just need to find a way for them to talk to each other again. Instead, single responsibility does not mean one script for one thing. It means one reason to change, which, put another way, means that the things that need to change together should be kept together. So what does that look like in practice? Take a movement script, for example. Let's say that you've got a player character that can move and jump. If you're good with numbers, you'll have noticed that that is two things. 3 when you realise that you're going to need to put a ground check in there as well. Which, if you took single responsibility to mean one task per script, means writing 3 different scripts. Now, there are benefits to this, since you'd be able to create objects that can only jump, only move, only check if they're grounded, or any combination of the 3. But in reality, trying to split these systems out can be more difficult than keeping them together. For example, they all use the same data. They may reference the same external components, such as a rigid body, and generally they all add up to one thing, moving the player. So is it okay to put them together? At this point, it's up to you to decide what one responsibility means, and you'll need to decide if any one part of this combined system will need to be changed separately to the rest. For example, is it likely that you'll need to create other objects that can be grounded, but that don't need to be controlled through moving and jumping? Maybe. In which case, you may choose to split out the ground check into a different component to avoid writing it in 2 places. But now you have to find a way for the movement and ground check scripts to communicate with each other. This is the drawback with single responsibility. It has the potential to reduce cohesion between your systems, meaning that while they're easy to add and remove, they're not necessarily easy to work with. So what's the answer? There is no one rule, but the general idea is to try to recognise what needs to be separate, but do it in a way that doesn't reduce cohesion. For example, in this case, if all movable objects require a ground check, but not all movable objects can be controlled, then it's possible to share the functionality that is common to both of them using inheritance, separating their functionality without reducing cohesion. It can help to remember that single responsibility is a two-way street. It's not just about separating things out, it's also about keeping things that change together. After all, the entire point is to make your game easier to work with, not harder. Separating every class into different small parts, just for the sake of adhering to a best practice rule, may be helpful in some cases and unhelpful in others. Especially since splitting up one script into 2 classes means finding a way for them to talk to each other again. When dividing a large class up into smaller parts, it can be easy to do it in a way that doesn't actually separate them. For example, imagine a movement script triggers a fire display script. You might decide that these are 2 separate things and that they need to live in different scripts. So you take the fire logic out, put it in its own class, and control it remotely from the movement script. Except what is actually different here? Because the movement script directly references the fire script, it's not really a separate system. All you've really done is write one script in two places. And if we're being picky, this also technically violates at least two of the solid principles, namely open-closed and dependency inversion. Now, if this is the only way that things move in your game, then it may not be a problem. But if the point of separating the movement script from a system that simply responds to it is to keep both elements modular and reusable, then the connection between them needs to be abstract, meaning that it's not specific to either one. For example, instead of controlling the fire display directly, it might be easier to use a movement event that the fire display subscribes to. This would allow the movement system to be used with or without a fire display, and with other systems passively. The movement script never really needs to know what other classes are doing with its data. If the fire display is designed to only work with this kind of movement script, then you can access it directly. But chances are you may want to create different types of movable class that could each be used with a fire display or with other types of system that respond to movement, such as a missile, for example. In which case, to make the connection completely abstract, implementing a movable interface, which would allow the fire display or anything like it to interact with any kind of movement system, can help to keep the systems in your game easier to swap out, test, or extend later on. While you won't need to do this for every connection in your game, it can help to consider the end result of doing something in a particular way, since how easy your project is to work on will be broadly defined by how easy it is to change, meaning that a little consideration now might go a long way later on. Now I want to hear from you. How are you separating the logic in your game? Are you using single responsibility, large classes, or a different method? And what have you learned about managing your game scripts that you know someone else would find useful? Whatever it is, let me know by leaving a comment, like this video if it helped you, or get subscribed for more videos from me. And if you're serious about learning how to code in Unity, try my in-depth course where you'll learn the basics of C# scripting, including the solid principles, and other best practice approaches for structuring your code. The first 100 customers can get 50% off using the link in the video description. I'll see you next time.